So in this session, we're going to talk about air pollutants, and we're going to talk about the main 6 air pollutants, which are called the primary pollutants. And then we're also going to discuss the secondary pollutants. These are not directly emitted, and these are actually formed in combination with other pollutants that are within the atmosphere to create new pollutants. So these are, for instance, if we're talking about sulfur dioxide, a secondary pollutant could be SO3 or could be acid rain. Same cases for NOx, which is nitrogen oxide and nitrogen dioxides that can create also acid rain or nitric acid. Also in secondary pollutants, we're talking about ozone, and we're talking also about smoke, photochemical smoke. So we discussed before that we have different sources of air pollutions, and we have some sources that are mobile and some sources that are located in a point. So these are called point sources. We have industrial, commercial, natural sources, and also transportation related sources, right? So mainly we're going to talk about the movement of contaminants for the following section, but in this session we're going to discuss about the main effects and the main sources of each pollutant. We're going to start first discussing the first 6 pollutants, primary pollutants, that are listed on all the Environmental Protection Agency list all over the world, and this is the one that we discussed before, which is the Australian one. The problem with these pollutants is the health effects to humans, but also the environmental effects. The first pollutant that we're going to discuss is carbon monoxide. This is a gas that forms from an incomplete oxidation. So this gas is mainly formed when the combustion process occurs without enough oxygen, or when the flame of the temperature is low, and also when the gas residence time is not enough in order to complete the combustion process that will allow the process to release CO2 or carbon dioxide instead of carbon monoxide. In urban areas, carbon monoxide comes from the exhaust of internal combustion engines, such as the ones in motor vehicles or other type of engines, and in natural environments it can come from fires, from natural fires. It can also come from the incomplete burning of various fuels, including wood or even garbage. It is worth mentioning that the emission of carbon monoxide has greatly decreased thanks to the improvement of these engines, and now the only problem that we're facing is, of course, the complete oxidation, which results in the generation of carbon dioxide, which is the main greenhouse gas, anthropogenic greenhouse gas, causing global warming. The second primary pollutant that we're going to discuss is nitrogen oxide, and which is NOx, known as NOx. These pollutants are formed during high temperature combustion in the atmosphere, and this is when oxygen combines with the nitrogen. So the nitrogen that is actually present in the atmosphere. So motor vehicles are the major sources of nitrogen oxides, and also electrical power generation plants. And around 80% of the nitrogen dioxide in cities comes from motor vehicles. The problem also with the generation of NOx is that it reacts in the atmosphere and produce photochemical smoke, and also it can produce nitric acid, which is another form of acid rain. Another primary pollutant is volatile organic compounds. These volatile organic compounds are basically can be gasoline, benzene, and also some products that we use on our households for cleaning or for cleaning operations, right? These are very important because they play a key role on the creation of photochemical smoke. So therefore, regulation is based on the potential of photochemical smoke. Another primary pollutant is particulate matter. The problem with particulate matter is the size of this matter. It can come from natural sources, and it can come from anthropogenic sources. These are solid particles that are combined with liquid droplets, and this size of particles can enter the lungs and can create health problems. So major components of particulate matter include sulfate, nitrates, ammonia, sodium, chloride, and carbon, mineral dust, and water. And the composition and sizes vary a lot. But what I'm showing you here on this figure is that this particulate matter is very small as compared to, for instance, a hair, and this can allow you to understand how easily can enter in your body and can affect your health. Here regulation talks about PM10, which is particulate matter less than 10 micrometers, and then we also talk about PM2.5, but also PM1. So we were talking about the major sources, and we were talking about also pollen, cells, bacteria, and these things that are also trapped in liquid droplets and also in dust in general. It is worth mentioning that particulate matter, some of these particulate matter can be formed in the atmosphere due to some photochemical processes. So when we're talking about, for instance, air pollution as particulate matter, we need to know that this type of pollution it can be even at macro scale, not only at meso or micro and meso. It can also be at macro scale, because it affects more than local communities or regions. So we have in Europe, there has been some problems because of the transport of sand, Sahara sand, that comes from the north of Africa till many cities, European cities. So you can imagine that this can be seen as a macro problem. So when we're talking about micro scale, we're talking about indoor pollution of particulate matter, and this is due to cooking or heating, or the uses in the when they're using wood or coal. This is another example of macro scale problem of particulate matter. So bushfires are typically sources of dust due to the combustion process, and these gases and these small particles that are also trapped in water can travel long distances. So when we had this big fire at the end of 2018, in some cities, such as Brisbane, we were suffering from this particulate matter, even though the fires at the beginning were not that close to the city. Another example of air pollution associated with particulate matter is here in Launceston, Tasmania, where there has been exceedances of PM10 since 1997. And this is mainly due to two main reasons. One, that Launceston is in a valley area that allows the conditions to the entrapment of these pollutants during immersion. And the other reason is that the use of wood materials for heating of households, and also for many combustion processes. So after these events, of course, regulation is what matters and what creates changes. There were some initiatives that allowed to have a better, cleaner air and the reduction of particulate matter. So as I mentioned to you before, particulate matter is a macro scale problem. And another reason for that is that aerosols are particulate matter, aerosols of SOx, SO2, SO3, and NOx, NO, and NO2 affect the reflection of sunlight when they're present in the atmosphere. So they have an implication on also global warming. let's talk now about sulfur dioxide. One of the main problems of sulfur dioxide is the generation of sulfuric acid. The problem with the sulfuric degeneration is the acidity, and it doesn't have a big difference as compared to the normal rain, that is a pH around 5. This slight change in or decrease of acid in pH creates a lot of environmental and human problems, and also have problems of in construction on buildings that can also be can be very costly. So what I'm showing you here on these pictures is just these sculptures that had been damages because of the acid rain. I also have to mention that this is called acid rain, but it's only the combination of the acid, sulfuric acid or nitric acid in the case of NOx with water, but it can be in the form of snow, or it can be in the form of vapor, or water vapor, or fog, for instance. Interestingly, late in the 80s, it was decided that to avoid this problem, this local problem, or that affected some communities near industries where there were combustion occurring of fossil fuels, that they will increase just the height of the stacks, and it was believed that the sulfur dioxide will have a better dilution with air. And what happens in reality is that this sulfur dioxide could be actually transported to other areas. So this is what happened in 1984, when it was estimated that in Germany only 1/3 of the forests were dying, and that thousands of Scandinavian lakes were basically without any life because of acid rain. So also problems associated with sulfur dioxide are related to burning, to fires, and also, as you can see here, fires that occur actually in the Mediterranean areas, where these pollutants were transported to northern regions and also were spread out and create also pollution problems. Now we're going to talk about lead. Lead was intentionally added to gasolines in the past in order to improve the engine operation. Lead was also added to paint, to cosmetics, and other things that we were using on our daily lives before knowing the associated problems, which were related to the bioaccumulation into the body and some detrimental effects mainly on children, right? So here on this figure, what you can see is how the implementation of a standard led to a significant decrease of lead levels in urban sites. So now let's talk about secondary pollutants. Secondary pollutants are created because of the combination of some of the primary pollutants along with sunlight. One of the most important ones is the ozone, and we just have to remind us that there is a good ozone and a bad ozone, and the bad ozone is the one that is being created at the troposphere level, and the good ozone is the one that is created on the stratosphere, and is the one that allows to impedes the passing of UV rays into the earth, right? What happens here is that NOx, NO2, with sunlight releases the oxygen, that is one of the oxygen atoms, and this oxygen reacts with the O2, the oxygen that is present in the atmosphere, to create ozone, or O3. This could be a reversible process. However, due to the presence of volatile organic compounds, the oxygen cannot go back to the molecule of NO to form NO2, and therefore ozone is remaining in the atmosphere. This figure shows the optimal times where to allow the formation of ozone in the ambient. So you can see that in the morning there is a high increase on vehicles and traffic that allows the release of NOx. And this occurs mainly in the morning. And then later at midday, you can see that there is an increase, obvious peak of ozone formation, because there is the presence of NOx, but also the presence of sunlight that is being required for the formation of ozone. Then later in the night, you can see that the ozone concentration is decreased, and this is because it dissipates in the night, and also due to the lack of sunlight that impedes the formation of new ozone.